We are okay. Let's keep washing our hands and do the needful so that we can overcome this deadly disease. Today, back again, we are still on light, and then today we are looking at reflection of light. Having looked at the introduction and all other aspects, let's now go to another subtopic here, that is reflection of light. We are all able to see other people or object as a result of reflection of light. Take an example. When we are in darkness, we cannot see anything, but when light is there, we are able to see. So that is as a result of this topic, reflection. So let me ask ourselves, what is reflection? Reflection is the process by which light energy falling on a body surface bounces off. So as a result of bouncing off, it comes to someone's eyes, and then you'll be able to observe. The surface from which reflection occurs is called a reflecting surface. That surface is what we call the reflecting surface. You know very well there are very many reflecting surfaces. We have mirrors. Light can be reflected from walls, the roof, and everything that is surrounding us. Then under here we have the rays that we use, or that the types of rays that normally take part in reflection. Remember, from the start we looked at a ray. Now we are looking at types of rays under this subtopic. We have what we call the incident ray. Incidence comes from the word to like, to come, to fall. So incident ray is a ray of light from the source, from the light source, falling onto or striking the surface. This is the first ray that comes from the source of light and hits the surface. Then we have what we call the reflected ray. The reflected ray is a ray leaving or bouncing off the reflecting surface at the point of incidence. So at that point, when the other one falls on the surface, it is reflected back. Oh, that one that bounces off into your eyes so that you can see the other object is what we call the reflected rays. So it's the reflected rays that reach us, the observers, and then the incident rays hit the objects which we observe. Then we also have another line. It's a line, it's not a ray, it's a line. This line separates between these two rays, the incident and then the reflected. And this one is called the normal. Normal is a line at 90 degrees with the reflecting surface. Is a line at 90 degrees with the reflecting surface. The ray is incident. So that line at 90 degrees is what we call the normal. Then under this, since we are saying we have that line that separates these rays, we have these rays, so we have angles which these rays make with this normal. And these angles, we have the incident, the angle of incidence represented by small I, is the angle between the incident ray and the normal at the point of incidence. Take note, the normal is not a ray, it is a line. So that angle between the normal and the incident ray is what we call the angle of incidence, i.e. it is the angle made by the incident ray with the normal at the point of incidence. We saw that when the incident ray comes, it bounces off. So it bounces off, forming the reflected ray, and also the angle that the reflected ray forms with the normal is what we call the angle of reflection. At the point of incidence, that point at which they all meet or fall is what we call point of incidence. Then we have a diagram here trying to show us those rays. We're having the normal is there. It must not have arrows. the normal line must not have the arrows, just a line at an angle of 90 degrees with the reflecting surface. Then we have that one that comes showing an arrow coming towards the surface, is what we call the incident ray. And then we have this one that bounces off, that is what we call the reflected ray. All of them are at one point. You're seeing that point is called the point of incidence. So the angles are there labeled. So we have some explanations here. You can see, go through, and then that takes us to the laws of reflection of light. We shall pick up from there.